Hello Finxter, welcome to this tutorial on Minima scaling. Before we dive into our tutorial, let's look at the summary of what we'll be talking about today. We talked about Minima scaling and scaling in general, why scaling is required. We speak to SKLN Minima scaler. Then we discuss how to scale entire column in a Pandas data frame. We also look at two approaches that we could use to scale specific columns in Pandas data frame. Okay, so let's go right ahead into it. So what is scaling? Minima scaling is a normalization technique that enables us to scale data in a data set to a specific range using each features in that data set. We use each feature's minimum and maximum value to determine the scale of data when we use minima scaling. Unlike standard scaling, where data are scaled based on standard normal distribution with mean 0 and standard deviation 1, the minima scaler uses each columns or each series minimum and maximum value to scale the data series. So why is scaling even required? The scale of data for some of our features may be significantly different from those of others, and this may harm the performance of our machine learning model. This is especially the case with algorithms that rely on a measure of distances, such as neural networks and KNN. Scaling is also helpful when we need to optimize our machine learning processes. As an example, when we're running graded descent, because the data are already scaled, the convergence will happen a lot faster. Scaling can help us improve the performance and speed of execution of algorithms. Again, since the data are already scaled down, complex calculations required to optimize our algorithms are going to run a lot faster. Scaling can be helpful when we need to compare two sets of model or two data sets based on their performance and see which one is better. So scaling helps in all of this area. So let's talk about SKLN Minima scaler itself. The SKLN Minima scaler has been used in many machine learning applications such as computer vision, natural language processing, and speech recognition. We will use the fit transform method of this minima scaler SKLN library to implement scaling of features in our data frame. In this tutorial, we will also show how to implement this on specific columns using two approaches like I mentioned earlier. I will describe this approach of converting an entire column in a data frame or specific column using the Python Indian diabetes data set from UCI, and I will show various ways on how this scaling can be done successfully. Now let's go deep dive into our code. So we have our code here. The first thing we need to do is to import the Pandas library, as you can see here. In the Python Indian diabetes dataset, we have 9 columns, with the last column, which is the class column, representing our prediction. So if the class is 1, that means the patient has diabetes. If it is 0, then there's no sign of diabetes. So we read in our data into our Pandas data frame. Then we can look at the top 5 records just to see how the data has scaled. Let's run that. As you can see, the scale of the data are quite different. Just take an example of the first column and the third to my right column, which is Pedi. So Preg and Pedi, we can clearly see that these columns are not of the same scale. So we need to scale our entire columns so that they have the same scale and our machine learning model is not impacted. We can further describe data to see how they are spread and also confirm that they are not of the same scale. So let's run that. the minimum and the maximum for all our columns varies, and the scale of the data are quite different. We can also look at this graphically, that the columns are not of the same scale. This will take a little while because of the graph. So now we have our graph. As we can see, the columns are not of the same scale. Take, for example, the first column, which is preg, then unit digits, while test is in hundreds. So clearly the columns are not of the same scale, and we need to scale, rescale, and make sure they have the same scale so that it doesn't impact our machine learning. But before we do that, let's take away this class column, as is not required in this tutorial. We are not making any prediction in this tutorial. We're only trying to scale our data in preparation for processing. Okay, so let's do that. As you can see, the class column has been taken away, and we have all the other columns left. So the next thing we need to do is to import Minima Scala from the SKLN library, which is what we're doing here. We create a copy of our data frame. The only reason why we're doing that is because we would like to use the original data frame again to show some other examples at other section in the tutorial. So we have that. Then we create a variable for our Minima Scala. We get all the columns from our original data frame here. Then we run the fit transform method on our entire Pandas data frame, and we specify our columns. Okay, so we'll run this and get the top 5 records just to see that all the items are now scaled. As you can see, all our records have been scaled. All items have been scaled successfully. They are now of the same scale. To further confirm that, we can run this subscribe method, which would show us that the maximum and the minimum value are now the same. So all our items are clearly using the same scale. The maximum now 1 and the minimum 0 for all of them. So we've been able to scale our entire data frame, all the columns in our data frame. So we could have situations where we are required to scale specific columns in our Pandas data frame. So in this case, we do not intend to scale the entire columns in the data frame, but only some specific columns. Okay, so for us to do that, remember we kept a copy of our data frame. So let's confirm that it's still intact. This is the original data frame that we got before we scaled the entire column. So we are going to use that again, and we are going to scale specific columns in our Pandas data frame. So assuming we intend to scale only the first 2 columns, preg and plus, we can do that using the same Minima Scala. However, we would specify only those columns instead of our entire data frame like we did before in the fit transform method. Please pay particular attention to the double bracket here, and we have the columns in between that. So we can check the top records again in our scaled data just to confirm that we've been able to scale our items successfully. So let's run that. As you can see from the results, we've been able to scale our first 2 columns while the other columns maintain their original scale. We can run our describe method again to show clearly that the first 2 columns are now of the same scale. You can see that the first 2 columns now have a minimum of 0 and maximum of 1, while all other columns maintain their scale. Another approach that we could use to scale specific column is to create our own predefined function and use the formula that the SKLN Minima Scala uses under the hood, which is this. So we take each of the value in a data column, subtract the minimum value in that column from that value. Then we divide the entire result by the difference between the maximum and the minimum value for that particular column. So we've created a function here, and we supply our data frame into that function, and we specify the column we intend to scale. So let's run our function. We would be using preg and plus again, which are the first two columns. We only want to scale those two columns and leave the other columns unscaled. So let's run again. As you can see from the output, only those two columns have been scaled, while the other columns remain the same. We can use our describe method again, just to show clearly that the first two columns are now the same scale. Their minimum is 0 and their maximum is 1, while the other columns maintain the original scale. So in this tutorial, we've been able to talk about Minima scaling in general. We looked at how to scale entire columns in the Pandas data frame. We also explored two approaches that we could use in scaling specific columns in Pandas data frame.